Hey, what's going on guys? It's Ilabella here. I record stuff on YouTube, check description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel, give me a big thumbs up to support it, and this is called lowest common ancestor of deepest leaves. Given a rooted binary tree, return the lowest common ancestor of its deepest leaves. Recall that the node of a binary tree is a leaf if and only if it has no children. The depth of the root of the tree is 0, and if the depth of a node is d, the depth of each of its children is d plus 1. The lowest common ancestor of a set S of nodes is the node A with the largest depth, such that every node in S is in the subtree with root A. Well, let's look at those examples. We got root 1, 2, 3, and we return 1, 2, 3. The deepest leaves are the nodes with values 2 and 3. The lowest common ancestor of these leaves is the node with value 1. The answer returned is a 3-node object, not an array with serialization 1, 2, and 3. Right here we got 1, 2, 3, and 4, and we return 4. Here 1, 2, 3, 4, 5, and return 2, 4, and 5. The given tree will have between 1 and 1000 nodes. Each node of the tree will have a distinct value between 1 and 1000. Well, I'll show you how to solve this problem recursively. We will be doing the depth first search. Go ahead. All you need is the maximum depth, 3 node, which is the lowest common ancestor of deepest leaves. Here we initialize the maximum depth 0, and we need DFS, which is depth first search helper method. We pass root and the current depth, which is 0 because we are at the root, and return the lowest common ancestor of deepest leaves. Here we implement DFS, 3 node root, and the current depth, and at each recursive call we are trying to update the maximum depth in the case when the previous maximum depth is greater than the current one, the maximum depth. We do nothing, otherwise we update to the current depth. And also we check in the case when the root is null, we return the current depth. And otherwise we got two cases. We go left and right. Int left is equal to, we call DFS recursively. We pass root dot left because we go left the current depth plus 1, and int right is equal to DFS root dot right and the current depth plus 1. And in the case when the left is equal to the maximum depth and the right is equal to the maximum depth, what we do is we say the lowest common ancestor of deepest leaves is equal to the root. Finally, we pick up the biggest, you know, value, math.maximum, which one is bigger, left or right, left or right. And that's the whole problem. Let's run this code. Accepted, good. Let's submit. There we go. So let's look at this example real quick. We got 1, 2, 3, and 4, and you know, that's like for example, like 1, then you can imagine the 3, 1, 2, 3, and then 4 right here. Okay, 1, 2, and 3. That's a regular binary tree. So we are at the position of 1 at the root. We are here. We initialize maximum depth to 0. Then we call this method DFS, pass root, which is 1, and 0 means the current depth. We enter this helper method, and right here we we do nothing because the maximum depth is equal to 0. So the root is not equal to null. We skip this condition. We go here. We go left. We do the depth first search. We go left, right? We go left, left, left. Then right here, and at each recursive call we add 1 to the current depth. So right here we would have 1, right here the current depth, then 2, right, then 2 right here, 1, 2, 3, and 4. Yeah, 1, 2, 3, and 4. Right here we would have 1, then 2, right, and right here 3. Then my maximum depth is equal to 3. So the root is equal to null. Right here to your left, you can see there is no child to your left on the left hand side. So the maximum depth is equal to 3. Then we start backtracking. We go here. We call this method recursively, right? Okay, and root.right, then current depth, which is 0, 1, and 2, which is 2. 2 plus 1, we got 3. Right here 3. We go here, the maximum depth is already 3. We do nothing. The current depth is also 3. The root is null, so we return the current depth, which is 3. And we again we are here, right? So left, which is 3, is equal to the maximum depth, and right, which is 3, is equal to the maximum depth. So we update the lowest common ancestor to the root, which is 4, and then we go on backtracking. We go we go here, right? We go from the bottom to down, like from the bottom to the top. That's what we do. And finally, we return the lowest common ancestor, which is 4 right there. Because, for example, right here at the position of 2, right, we got left, which is which is 3, right, which is 3. Then because we return, return 3 right here, from this point we got 3 left. Right, we go right, and we ain't got no child, and current depth is equal to 1. 1 plus 1 is equal to 2. And right here at this point we check left, which is 3, is equal to maximum depth. That's right, but right is not equal to the maximum depth, because right here we got only 2. So we skip this condition and we return 3. That's it. That's, as I said before, the whole problem. Thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias. Follow me on Instagram. Add me on Snapchat. And I wish you all the best. Bye.